sheet. This is we're going to set it up the same, kind of the same way. This is like almost setting up the same way that we did on the back side when we talked about segments. Yeah, I know it is. I'm trying to draw a circle really fast. None of my circles and ovals that are on your guys' WebQuest scanned. It looks like crusty old lady fingernails or something. It's really gross. I don't know how to explain it. It's just nasty looking. Okay, so when we look at our kind of like our bow tie, we know that this has the vertex. Oh, wait, I want to write that in the circle. Sorry. This is vertex in the circle. Just like on the back side, we had vertex in the circle, vertex on the circle, and vertex outside the circle. We don't have anything on the circle, but we do have a vertex outside. Let me get if I can spell that. Outside the circle. Okay. So if the vertex is in the circle, it's created by two chords. So I'm going to redraw this little doodad right here. And these are my two chords. And they are labeled segments A, B, and segment C, and segment D. Okay, so this looks like a bow tie. So what's the reason or the formula that we use this? We take the products, dang it, I'm not able to talk and type at the same time. All right. We take the products of the pieces of the chords. So we are going to take A times B and set it equal to C times D. Products of the pieces of the chords are equal. The product of the pieces of the chords are equal. That was the first one that we learned, the first theorem that we just did today, okay? So when I look at these theorems here, can someone open that door for me, please, and thank you? So hey, Gary, yeah. So you need to go back and show your work because I don't have GoGuardian for you guys. So I have no way to know that you didn't use Delta Math or you didn't use Desmos. Did you use Desmos at all? No, yeah, you got to show your work, especially where you're graphing your solutions.
I can't go back into the test.
Sure you can. You get 2 attempts, so you can go back into it. And you get to see your test results. Do you see where it says how do you guys review your quizzes results? This one can. I've got it set up that you can review it.
I'm pretty sure you can after you did it first. Pretty sure there's a button that says somewhere. Yeah, if you did the first quiz.
So take it again and don't worry about answering it. Just show your work. You got to show your work. Okay. I know that was part of the directions. You got to show your work. How are you doing? Which one?
I just don't understand. Stuck.
Are you going to stay after school one day with me? You need to.
Well, I'm going to the game today. So
Okay, so let me show you. The two equations that you're given to solve are in this form. This is your slope, and this is your y-intercept, which is where you always begin. Okay. Let me grab one more. I'm going to do 2 samples for you. Guys, you think you can fill that out? look at your lines. Let's see, those look like tangents, two secants, a tangent and a secant. Try it. Okay, so I'm going to just make up two equations. Y equals 2x minus 5 and y equals 1/2 x plus 2. So when I look at this first equation, my slope is 2, and I write it as a fraction, 2 over 1. My y-intercept, where I begin, is negative 5. So I'm going to begin at negative 5 and then up because it's positive and we always run to the right. So up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. So that's this line right here. Y equals 2x minus 5. Let's look at this line. So my slope is 1/2. That means I go up 1 and to the right 2. And my y-intercept is 2. That's where I begin. So I'm going to begin at 2. And I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. So when I graph these, this is my solution. That's where they intersect. On your test, they're exact points. Like it's going to be like right in the middle of the grid line. Okay? You get 2 attempts on this, and if I need to give you a retake, I will. I have a key that I worked out. So once you guys get done with all of these, if I need to, I'll post it and message you the key, or I'll just make a copy of it for you. Okay? Just so you can see, and then I'll just write a new quiz for you if you need to do a retake. Okay? We'll just change up some of the questions. Okay? Perfect. You know, I see after every day until at least 3:30.
I'll be here.
Okay, I would love to see you. Thank you, ma'am. Okay, so we have 2 tangents. Looks like this next picture is 2 secants. And then it looks like this last one is a tangent and a secant, right? So let's see. My 2 tangents. Well, remember that tangents to a circle that come from the same exterior point are congruent. So tangents from the same exterior point are congruent. So that means that A equals B. That's what that means. When I look at my 2 secants, gosh, this is such a horrible picture. So sorry about the quality of my scan, you guys. So these are my 2 secants. This is the outside, and this is the whole piece, right? Outside, whole piece. So remember that the whole segment, the whole secant, multiplied by the outer segment is equal to the whole multiplied by the outer. I'm just going to write it like that. And then I'm going to write out equals out. So just the out. Outer times the whole equals the outer times the whole. That's how I should have written that. Outer times the whole equals the outer times the whole. That's really how I should have written that. That would have been much more concise. And then this last one is a secant and a tangent. The tangent is this right here. And then my secant is this right here. I have an outside and a whole. So outside or outer times the whole equals the tangent squared equals the tangent squared. So I have it labeled as A, so A squared equals out. A squared equals out. Now I do have 3 special cases. Are your guys' special cases drawn on your green paper? No? Okay. So we have 3 special cases. So I'm going to just do 3, like make 3 makeshift columns. So these are our special cases. Just like we had special cases on the front side, we have some special cases here. Okay. Our first one is, remember that a radius is perpendicular to the tangent at the point of tangency. Right? So when the radius connects the tangent together, we know that those are perpendicular. So let's kind of draw a sketch of that. So if I have, this is my tangent. I'm going to say here is my point of tangency. Well, this radius is perpendicular to that. This radius is perpendicular to that. So how do we solve for this? How do we solve for something like this? Well, we're going to have to remember Pythagorean theorem. A squared plus B squared equals C squared. Or we might have to find an angle measure, right? So we can find like the measure of a chord, the measure of a arc. So we might even have to use some SOHCAHTOA. And I made sure that when we did our journals yesterday, I put examples in there like that. We did an example of both of those. Okay. Another special case is when you have 2 chords that are congruent. So equal chords have equal arcs. So if you have congruent arcs marked, you know that the chords that created those arcs are also congruent. So like if this measure, I'm going to try to turn this into a little example. If this was 8 and this chord was labeled x minus 2, and you had to find x, what would you do?
Equals x minus 2, and then I
Yeah,
add 2, and then will that be it'd be 10 equals x.
perfect. Did you guys hear Reese? He's like, well, if those are equal, then I would just say 8 equals x minus 2. That's where it's important to know, because sometimes you're going to have to figure out the measure of those chords, and you won't see that, right? Last one is when you have a radius that's perpendicular, a radius or a diameter. I said it could be a radius or a diameter perpendicular to a chord. What happens here? Do you guys remember?
The chord is bisected.
Yeah, the chord and the arc. So when you have a radius or a diameter perpendicular to a chord, the chord and arc are both bisected. Now we're really focusing on segments. So if I were to call this A and B, because this radius is perpendicular to this chord, I know that A is equal to B. I also know that this chord arc piece, arc section is congruent to that arc section.